So in this video, we will be talking about how to calculate molarity or how to get moles or liters out of molarity. So what molarity is the concentration of solutions, and so it's moles per liter. And so if you have grams first of a certain substance like NH3, then you'd have to convert it in order to get moles and then divide by the liters. But if it were milliliters, then you'd have to convert the milli to the liters. And one important thing is that molarity is always an uppercase M, because if it was a lowercase m, it would be confused with milli. And so for calculating molarity, you would do moles over liters. So if you had 3 moles of NH3, then you would divide it by your 6 liters of water and you would get 1/2. So then that would be, your molarity would be 0.5. Or if you have 2 moles of NH3 and 6 liters of water, you divide that together and get 1/3, and so your molarity would be 0.33. So what it is if you have a higher molarity, you have a higher concentration. So this is why if you leave a soda out in the sun for too long, then you come back and it could be diluted. So if you have a bigger mole on top than liters on bottom, then it won't be a decimal or a fraction. So if you had 6 moles of NH3 and 2 liters of water, you would have 3, or a molarity of 3. Or if you had 6 moles of NH3 over 3 liters of water, you would have 2 molarity.
Okay, so now we're gonna rework the formula, which is something that we can always do in chemistry. So we know that molarity is equal to moles per liter, and this can also be reworked by multiplying this side by liters, which equals moles. So you have molarity times liters equals the moles of a substance. This is especially useful when you have these two knowns and this is your unknown, like in a stoichiometry problem. You have the molarity of a solution and the total number of liters, and you're trying to find the moles so that you can do stoichiometry. This is the equation that you'll most likely want to use. And then lastly, we can divide the moles by the molarity to equal the liters. And this is what you use when you have moles and the molarity and you want to find how much of the substance there is in total. So we're just going to do a couple of practice problems. So if you have, say, 30 grams, you probably want to work this along with us with a calculator, that way you can understand how to do it. So if you have 30 grams of NH3 and you want to find out what the molarity of it is, the number, or the molarity of it, then you first want to convert it to moles. And you do this by using the molar mass we know. So 1 mole is equal to, and I already have this looked up, so it's 17.031 grams. Now I'm going to use my calculator and do 30 divided by 17.031, and that equals 1.7615 moles. If we're doing sig figs, we'll just do 2, but it's okay. And say we have 50 milliliters. Now you want to make sure that you're doing this in liters, so you want to convert your milli to liters. So that means moving the decimal over 3 places, so you have 0.05 liters. And then this number divided by 0.05 will give you a molarity of 35.23, which is a really big molarity, but makes sense if you have that much of a substance. So that's how you do a practice molarity problem. Okay, so we're gonna work a practice problem now, and this is how to use molarity with stoichiometry. So right here we just have a basic reaction going on. That's an equilibrium reaction. And it's just these 2 compounds forming these 2 problems, classic double replacement, but you're given the molarity in liters of both of the starting compounds, and you want to find how many grams of KNO3 is formed, so that's your end goal. So you have 0.3 molarity Ki, and then 4 liters of that, and 0.2 molarity PbNO3, and you have 4 liters of that. So the first thing we're going to do is we're going to use the molarity times liters equation to get the number of moles, because in order to do stoichiometry you have to know the number of moles. So I'm just going to use my handy dandy calculator, and we're going to do 0.3 molarity times 4 liters and that is equal to 0.3 times 4, 1.2 moles. And 0.2, we're going to do that as well. 0.2 times 4 is equal to 0.8 moles. So now that you know how many moles you have of each substance, you're going to have to do the standard limiting reagent method to find out which one is the limiting reactant, and then do like the molar relations in order to find out how much KNO3 is formed. So in order to find out which one's the limiting reactant, we do, oh sorry, that's not enough room. I just put it over here. So we have 1.2 moles of Ki, and then since this is imaginary 1, we'll just do it with the KNO3 since that's what we're looking for. And then 1 mole of that. Then it's in a 1-to-1 ratio, so you just know it's 1.2. And then for the 0.8, it's going to be basically the same thing. So since 0.8 is the smaller value, you know that PbNO3 is going to be your limiting reactant, and that's going to produce 0.8 moles of KNO3, because like I said, it's a 1-to-1 ratio for everything, so it's all going to end up with the same. And then now, since we're trying to go for how many grams there are, we're just going to convert these moles to grams, and I already have the value looked up for this compound, and it's 1 mole is equal to 101 grams, and the 0.8 times 101 is equal to 80.8 grams. And that is how you do molarity and stoichiometry.
Okay, so for dilutions, it's where you add more water, which will lessen the concentration of a solution. So this means that you would talk about how you have molarity and your liters. And so what you would do is that you would have your molarity for your initial concentration and then your volume for your initial. And then you'd either be given your molarity for your final or your volume for your final. And what you would do is that you would act, say if we don't have the volume of the final, you would act like this is X, and so what you would do is you would multiply these two together and then divide it by this, and it would give you this answer. Or if you didn't have your molarity of your final, then you would put this as X, and then you multiply this and divide it by the volume of the final. And then molarity, like we've said before, is moles over liters, and the volume is milliliters, liters, or anything like that, as long as you make sure that your molarity is the same. So if you're doing milliliters, then you have to use millimoles whenever calculating your molarity. And so what you would do is that your molarity and liters, they're always proportional, so it's kind of like an inverse relationship to where you can also, it's possible that you are not given one of these and then you have to multiply these to do it. So say that we're given like 0.5, if we're given 0.5 molar of your initial in 20 liters, and you have 40 liters as your final. So what you would do is that you would do 0.5 times 20, and that gives you 10, and so your 10 has to equal 40 times X. So what you would do is that you have to do your 40 divided by 10, so this would give you X equals 1/4, so your molarity would be 0.25.
Okay, for the next problem, it says you have a can of Coke, which is 400 milliliters. You add 0.2 liters of water. What is the molarity of the Coke with the water if the initial molarity is 2 molarity? Okay, first, you want to convert this to liters. So 400 divided 1,000 equals 0.4 liters. And this is your initial. So in the equation, and also since we start with 2 molarity, we have 2m times 0.4 L equals, and since we don't know that, that's what we're trying to look for. And then we have our final, which would be this plus this. 0.6 L. Alright, to solve this, you'd first multiply that, so 2 times 0.4, 0.8 equals molarity final, 0.6, and finally you just divide 0.8 by 0.6. And so for your final molarity, you should get 1.3 repeated.
Thanks for watching.